Today we will cover Chapter 11, Graphical Solutions. So today we have 4 learning goals. So first one is know 9 rules how to effectively visualize your data using a graph. And the second goal is know there are many different types of graph is available in the Microsoft Excel. So how to choose which graph, how to choose graph to represent your data more effectively. Third one is know graph interpretations, and the last one is graphical solutions. So basically number 3 and number 4 is you have to interpret the graph. So from the graph, how can we interpret the data and how we get some solutions. That's the things. Okay, so first before we go to the graph, we have to understand the concept is independent variable and dependent variable concepts. So abscissa is independent variable and the ordinate is dependent variable. So here is a simple questions. We have a graph. The x-axis shows the time, second, and the y-axis shows the temperature. And this is a scatter plot. The question is what is the abscissa in this graph? Is it horizontal axis or vertical axis? So whenever we draw a graph, think about like this. The x-axis always represent independent variable and the y-axis represent the dependent variable. So x-axis is the horizontal, x-axis means the abscissa. Okay. So here are 9 rules to effectively visualize your data. The first one is label both axes clearly. So here you can see the y-axis shows the left figure is power and the x-axis shows diameter. And the second rule is select the scale increment that are easy to read. So here we have 2 figures, but the left one shows a 0.4 increment and the right image shows a 0.5 increment. So in terms of clarity, I would like to recommend the right side images instead of left one, because it's easy to recognize the individual units. And the third rule is provide horizontal and vertical grid. So here you can see there are grid lines, so we can easy to find the data. So in terms of these 3 rules, what we learned the last page, what is the best graph in these 4 figures? Okay. So as you can see, x-axis shows the times, y-axis shows the vortices. The graph A, B, C, D, which one is the best one? Here you can see graph D has a horizontal grid line and a vertical grid line, and the depth of the line thickness is very clear to see the data patterns. So graph D is best among those graphs. So all plots must have a horizontal and vertical grid lines. The another rule, number 4, is provide a clear legend. So here you can see, we can see the blue dot indicates tank 1, the triangular, the red one shows tank 2. But here are different things. What's the difference between this left image and right image? The left image shows a scatter plot and the right image shows a line plot. So when we have a sample data, which is a small number of data, we want to see the trend, then we can plot using this scatter plot. That's a normal way. the line plot means there are so many data on the line, right? So this is kind of predicted or estimated using the equations based on what we have the data. So this is also shows a little pattern, but this pattern is more clearly shows the data which is not showing in this area, but this line shows the trend. So when we have data and just to show a trend and see some data itself, then we can use a scatter plot. But we want to see more specific trend and estimate the values, then we have to use the line plot. That's the difference. Number 6, use a different symbol and shape or colors. So here you can see the left image shows there's no features to distinguish 3 lines, but here we have 3 different color and 3 different symbols. That's good to recognize. And also always the graph produce graph in portrait orientation. And the 8, be sure to use the graph is large enough. Be sure to make a graph largely enough to easy to see. Also, please put the name very briefly and briefly but concisely. Okay. Let's criticize what is the problem of this graph. What is the problem? So first you can see that there is no label for x-axis and y-axis. Even though the title said distance versus time, but it's always better to put the label on the bottom and the left side. And if you see the increment is also it's consistent, but it's harder to recognize data. Why not just a 2, 4, 6, 8, 10? That is much better. And then there is no legend, so we don't know which one is which, the filled one and empty one. I'm not so sure what is the data set. And also the title is very limited, gives some limited information. It's we can add more information on here. So no x and y axis label, poor caption, no legend, no vertical grid lines, and improper scale increment. That's the problem. Alright, now let's look at the available graph types in Microsoft Excel. As you may know, there are different types of graph functions are exist in Microsoft Excel. There are 16 different types of graphs in Excel, such as line graph, pie chart, bar chart, area plot, things like that. Then how we can choose right graph to visualize your data. So first one, the rule of thumb is you have to understand your data type. Sometimes the data is a categorical data. Sometimes it can be a continuous data, or some such as anthropometric data, what we learned last times. It's continuous data, percent data, things like that. So understand the data type and then apply, choose the right one, the right figure to visualize your data effectively. So for example, we saw the scatter plot. The scatter plot is very simple plot. If you have a data set such as an independent variable and dependent variable, so it's easy to see some trend and how it looks like. And we also you can use interpolate and extrapolate the data features using the scatter plot. Here is some example about scatter plot. So basically we want to see some trend. We have a bunch of data. This is the US Army data, which is male data, 1,774 people. the x-axis represents the stature and the y-axis represents the sitting height. And you can see there are a number of dots here. This is indicate a person who belongs to this size, this stature, and this sitting height. Okay? And we can assume that if the stature is increased, then sitting height is also increased. So there is a highly correlations. The correlation coefficient is 0.7. So if it is 1, it's very highly correlated. But 0.7 is still very high. About the line plot, when we have to use the line plot, if you have a data related with time, then it's easy to see the data trend from the line plot instead of scatter plots. So for example, here you can see the Ford Motor Company. This is the stock price of Ford Motor Company in last year. We can express this stock price using scatter plot, but instead of scatter plot, we can simply draw a line so we can see some trend in terms of time. So if you have a time series data, then line graph is a good solutions to visualize your data. Line is easier to read a trend of data than bar chart. Okay? Then when we have to use a bar chart, if you have some categorical data, then or if you want to compare differences between some categories, then bar chart is good solutions. So for example, this is shoe comparisons. So the left one is general shoes and the right one is e-West shoes. So we have two categories here, and we want to compare the average force and the peak force. So you can see the general shoes should be left side. So when you draw images, the reference data should go left side first because that is a reference. And the right one is your data or improved data or revised one. So we want to compare the right one to the left one. So think about like this. So this is a bar chart. It's easy to compare compared to the line graph and the scatter plot. How about the pie chart? If you have a data which is a percentage data and display some categories as a part of 100%. For example, this category 5 is 30%, has 30% of our portion. So this is one of the application using pie chart. I just draw a pie chart that how many students, number of percentage of students want to go company, which company you want to go. So for example, 16% of our students mentioned that they want to go Lockheed Martin after they graduated. So now let's look at the graph interpretations. Okay, this is hourglass, so 10 minutes hourglass, and the sand flow rate is consistent, 275 cubic millimeter per second. So we know this value, and we want to design this hourglass. The thing is, the question is what volume of the sand will be needed to, we want to build 10 minutes hourglass if we have this much consistent sand flow rate. Okay, so 10 minutes is 600 seconds, so we can just multiply it, then we can calculate it. But if you want to see this graph, this is a time, okay, and the sand flow rate is consistent, 275 is consistent, and this is time. So the area under this curve, under this line, is actually the volume what we are looking for. Okay, so sand flow rate times capture the time, then how much volume we need to build this 10 minutes hourglasses. Okay. When you interpret the data, when you interpret the graph, you have to understand these three concepts: the slope of the line, and the slope of shape of the line, and the area under the curve. So you probably learned some mathematical formula in your calculus 1 or calculus 2. We can always convert acceleration to the velocity, velocity to distance, distance to velocity, velocity to acceleration, right? So what is the second derivative of the distances? Second derivative of distance is acceleration, right? We can also go to one integral or two integral, then we can find the values, right? So the horizontal line is that this is the horizontal line. The slope is 0. Okay. But here we have some kind of bar chart, but the slope is undefined. Okay. You can see if this is a horizontal line increasing, then the slope is 0, and the area under the curve is still increasing at a constant rate because it's a constant rate, 0 slope, and the variable is not changing. This is a non-linear plot. It's a linear plot. The previous one is a linear plot. This is non-linear. So if the x-axis increased, the y-axis, the values are exponentially increased, very fastly increased. So here we can see some examples. Mars rovers. Okay, this is a Mars rover. So it's a kind of a small vehicle. It goes around on the Mars and to investigate some certain site. Okay, so this is the velocity of the Mars rovers. Okay, and this is a time. The question is, between point D and E, the acceleration of rover is blank. What is this blank? What is the values? So you can see the velocity is around 4 feet per hour, but you can see the acceleration. Acceleration is not velocity. There is no acceleration change. The velocity is consistent. So here the acceleration of the rover is 0. The second question is the value of acceleration of the rover between point Z and H. You can see the rover's velocity is highest at G point and is suddenly dropped to H. So it's the zero velocity means it stopped. Okay, it does not move. Here was the highest velocity and the lowest velocity. And what is the acceleration of the rover? We can calculate this slope. Slope is accelerations. So this is a numerator and denominator. So we can find it. The acceleration of the rover is 30 feet per hour squares, which means it's negative 30 feet. So it's decreased. So velocity is decreased. 30. The last question is between point E and F. The distance traveled by rover is how much? So you can see the velocity is still in 4 feet per hour and slightly increased to the 6 feet per hour. So in this case, we can calculate how much distance they moved, how much time they moved, and which velocity they are associated with. So area under the curve, this red area is actually the distance of the Mars rover move around within this time. Okay, the area under the curve is the actual movement. Okay. The last concept is we can also find some solutions from a graph. Okay, let's see some examples here. Break-even analysis, which is very important concept for you. We have a fire ant plus fire ant destroyers. So you can see the x-axis shows the number of units, and the y-axis shows the cost or revenue. The red line indicates its total cost for a company, and the green line is sales revenue. From when we sell the product, then we will get a revenue. That is the the green dotted plot. Okay, so what is the break-even point? Break-even point is oh, by the way, about the cost line, this is the fixed cost. We start from here, so we already investigate this amount of cost for productions. Okay, so the slope of the cost line is actual the variable cost. Okay, and the slope of green line, the sales line, is the selling price. And the intersect between the cost line and the sales line, that is the break-even point. Okay, so from this break-even point, before the break-even point, we if we think about, we are the company guys and we make a loss. Okay, but after the break-even point, we can make we can generate profit. Okay, so we have to sell this fire ant destroyer until we reach this break-even point. That's the point. So once we pass through this the break-even point, we will get the money. But before that, we will lose the money. Okay, that's the issues. Here, how many fire ant destroyer we must sell in if we have this kind of graph? Okay, so you can see the black one is total cost and the orange one is revenue. The intersection between the total cost and the revenue, we could say around 170,000 units. If we sell this amount of fire ant, then we will make revenue from that point. Okay. All right, and then if we want to make a profit, $500,000, then how many cells do we need to? How many fire ant must be produced? And so this is this much is $500,000. So you can see it's dollar times 10 to the 6th. So you can see this is 0.5 increment. So this is $500,000. So we have to sell $260,000 units. Then the difference between cost and profit is 500,000. And what is the sales price of fire ant destroyer? Sales price is the slope of revenue line. So this is the slope. So we can calculate from this graph. So we can read some values from this graph. So it looks like, okay, we have a number of units, 0.5 times 10 to the 5, and the cost is 0.5 times 10 to the 6. So we can find it's $10 per unit. Okay, so let's think about in this way. We can sell the fire ant $10 per unit. But if we sell $11 per unit, or if we sell this $9 per unit, which one is go reach to the break-even point much faster? So if we sell $11 per unit, then we can fastly reach to the break-even point compared to the $10 units, right? Does it make sense? Okay, so for $11 per unit, we will reach the break-even point for 140,000 units. Okay, the previous one is 170,000 units for $10 per unit. But instead of increasing, then we can decrease also $9 per unit, but the break-even point 210,000 units for $9 per unit. Okay. Today we learned 9 rules for proper plots, and we also learned how to choose a right graph in terms of data types. And third one is we also learned how to interpret the graph. The last one is we can also find some solutions from the graph. Thanks for watching this short video. Have a great day.